Hi, today I'll be discussing how to find out if a given string contains all unique characters. We will not be using two for loops like I showed you in the previous video, and the runtime for that method was n squared, which is not good. Today I'll show you how to solve this problem by using bit manipulation in Java, and its runtime is going to be better than the one I showed you in the previous video. So let me explain the question once again. If we're given a string, our job is to find if it has all unique characters. If we're given A, B, C, D, we have to find out if this string contains all unique characters. A is unique, B is unique, C is unique, D is unique. So when does it become non-unique? When any of these repeats again, it's going to be non-unique. So for example, A, B, C, D, and if A repeats again one time or multiple times, or B repeats, C repeats, then this is called non-unique string. Here we'll find out if any of the given characters repeats itself by using an integer. We will set the information of the repetition into the bits of an integer, and we'll find out whether it's repeating or not. So before we move on to that process, let me talk about bits in Java. So in Java, an integer has 32 bits. So whenever we declare an integer like int 1, it will have 32 bits, starting from least significant bit, LSB, to most significant bit, MSB, and there will be altogether 32 bits. That becomes 4 bytes. So these all will be 0 bits, and the least significant bit would be 1. So this is the integer 1 in Java. So if we have to declare 0, then it will be 0 here. And all together, the size of this should be 32. That means it should contain 32 bits, and they could be either 0 or 1, but it can contain 32 bits. If you talk about long, one long contains 64 bits in Java. That means there will be 64 zeros or ones to represent a long, like this. And it's gonna be altogether 64. How can we solve this problem by using bit manipulation? So here's the logic. So how can we find out if it's being repeated again? By seeing its information in a container. So I have a container here. Now this container, let's suppose this is a container, and it contains the informations about the letters or alphabets. So there are 26 letters from A to G. So let's say this is the first letter, second letter, third letter, fourth. So we can also write like A, B, C, D, E, and so on. It goes until G. So this is the position of letter A. This is the position of letter B. Now, whenever we encounter A in our string, given string, so here we have a string str equals, let's say, A, B, X, Y, G, G. This is the string given to us. Now we are gonna go through the string and we'll see, is A present in the string? Yes. Then we're gonna update the position here. So if A is present, we're gonna make it 1. And we are gonna go again and see if B is present, we'll make it 1. X is present, maybe X is here, we'll make it 1. Y is present, here, 1. G is present, let me pull it here, 1. And again, now when this G repeats, we'll again go and see, is G present already? Yes, it's already 1. That means it's repeating. That's when we're going to return false. False. So how do we get this container? Okay. So for this container, we're going to use an int. An int 0. So when we declare int 0, this is what happens. We have int, let's say position holder equals 0. Now in Java, what's happening is this position holder will have 32 bits here assigned to this position holder. 32 bits. And since its value is 0, and in binary 0 means just 0, but depends how many bits does it have. It has to be represented by 32 bits. It's gonna have 32 zeros. Since it's 0, all the 32 bits will be 0. So here I'm gonna have 32 bits and which contain zeros. So these zeros and ones can be used as the information regarding a character. So we can find out the position of a character, and this position holder, let's say, let me call it position holder right now. So in this position holder, which has 32 positions, since it's made of an int, and int has 32 bits, it can hold the information about 32 things, let's say 32 characters. But in if you see the letters, if we see only lowercase letters, there are only 26. So 26 bits should suffice for this problem if we're just handling lowercase a to g. But if you want to handle more than 26, you can handle up to 32, but you cannot handle more than 32 because an int can hold only 32 bits. So if you want to go larger, if you want to hold greater number of information, then you can go ahead and use long, like 0. So when you have long, you're gonna have 64 bits. So you can hold the information about for 64 things here. 0 is information 0, 0, 0. So when you have like long p holder equals 0, then this is gonna have 64 zeros, and 64 zeros because the value is 0, and in binary it's just all zeros. So you can hold up to 64 bits. So you can put the information for 64 things or 64 characters. But right now, since the letters are only 26, I'm gonna use int. But I'll show you during while I'll be coding. I'll show you how we can use um, long for storing those information later. Now let me show you once again how we're gonna solve this problem using the integer. We'll declare an integer with 0 value, int position holder equals 0. So this will give me this container. Okay, I'm gonna delete the first one. Okay, now since it's an int, I'll have 32 bits. And the rightmost is gonna be, it's called least significant bit, and the leftmost, it's most significant bit, and all together there will be 32 bits. Now when I declare 0, these all bits would be filled with a bunch of zeros, all 32 zeros. Now I have an argument of string, and that string argument str, it contains a bunch of characters. Okay, this is unique. Let me have another which is not unique. Okay, now how do we solve this problem? By using an int, and this int is going to act as a container, like an array or like a hash table. So we're going to start from a. If there is a, then we're going to put here in the 0th, or let's say the first position from the left. In this position, we're going to make it 1 because this is an A. Now A has 1. That means A is already put in this position holder. Now we move on to B, and we'll put the B, we'll put in second position, and this is for B. We're gonna put 1. It was 0 in the beginning, but now we made it 1 because we encountered B. Now when we encounter C, we'll go to C's position and we'll put 1 here. And now so on, D here 1, and E will have 1 here. And remaining bits, they won't be used. So it's not gonna bother us. We don't need those. Right now, we were dealing with only A, B, C, D, E. So we used only 5 bits. Now, since these are not repeating, these all are ones. Now, once we put all information about the characters in a string, once we put here, now our job is to find out if so while we put the okay, let me rephrase it. So when we're putting the information about these characters, they did not repeat, so we don't have to go back and look them again. Now what I'm trying to say is, let me so it will make it clear when we do this string 2. So let's start over for string 2. So here these are all ones. We don't have to repeat, or we didn't have to um, go back and see again for the same letter or the same character. So what happens if we have any repeated characters? So let me put all these back to zeros. 0, 0, 0, 0, 0. How many alphabets here? A, B, C, A, B, C, D, no, A, B, C, E, F. So I think this is, let me make it B. So how many alphabets here? A, B, C, E. So I have A, 1, B, C, E. So 4. So we need only 4 bits. So when we encounter A, we're going to convert this into 1. Or change the bit into 1. And when we encounter B, we're going to change this into 1. Now again, here, this is where we will find out if it's being repeated or not. Now, after B, again we got A. Now, when we go back to see the position of A here, this is A's position. And if we go there, there's 1. That means once we find this character is being repeated, now we don't need to proceed further. Because if we have only, or at least one character which is repeating, that means the whole string is non-unique. So this is how we will find out if the string has non-unique characters, and this is very efficient. And it uses very less space, and it does not use any data structure because we're just using an integer. It's not data structure. It's not set. It's not map. It's not an array. Now you might be asking, or you might be thinking, how are we gonna say this is A's position, this is B's position, this one's C's position, this one's D's position? Okay, for that one, it's very easy. The reason being easy is all the characters, they have their respective ASCII numerals, ASCII number, ASCII values. A has 97, B has 98, C has 99. So again, you might be asking, this is 97, but this is the first position in the left, rightmost side. Pretty simple. If you subtract 97, it becomes 0. Now A can be corresponded to 0 position, and B, 98 minus 97, it's 1. So we can represent B by 1 position from the right. Okay, and C by 2. So this is how we correspond A, B, C's and their positions in this container. Now here, 97 minus 97, that's 0. 98 minus 97, 1. So what I'm doing here is I'm just subtracting from character. So whatever the ASCII value of that character will be used, and we're going to subtract the ASCII value of A. So here we are subtracting the ASCII value of A from ASCII value of A, so that becomes 0. And here we're subtracting ASCII value of A from ASCII value of B, which happens to be 98 minus 97, that's 1. So this is how we find the position of a character in this bit container. Now, after doing this math, so first we look for find the position and put the 1. Then later, if it repeats, we will break the loop and return false. Now, how to put 1 here in the container? Okay, so when we declare an integer, it's gonna give us zeros, a bunch of 32 zeros. That makes sense. But someone might be wondering, okay, now I know when I go through for loop, I know the position of A or B or C or whatever because I know the ASCII value. And I can subtract the ASCII value of A and find out the position is 0. But how someone's gonna change this 0 into 1? So to understand this, we need to understand some bit operations. So what are those bit operations? The ones I'm gonna use here, it's gonna be and another one is or. So these are the symbols. So and or. So how do these work? And means when there are two ones, then you always get 1. So if you end 1 and 1, you always get 1. If there are two ones, then that means if you end 1 and 1, that means two ones, then you get 1s. Otherwise, you always get 0. Don't forget that. If there are two ones, you get 1. Otherwise, that means if there are no two ones, that means if there's only one, and it could be anything else. So 1 and his 0, it gives 0. There's 0 and 1, it gives 0. There's 0 and 0, it gives 0. That means the rule you should not forget is if there are two ones ending, or if you're ending 1 and 1, you always get 1. And if not, any other situation would give you 0. That could be 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. So only look for these two situations. If you have 1 and 1, then you have 1, and otherwise you don't have to worry, always 0. That's about ending. Now how do we or? So or is, so and is about two ones. Now or is about 1. Okay, what I'm trying to say here. 1, as long as there is 1, I mean a 1, the quantity or the number of 1 is just 1. As long as there's 1, you always get 1. It sounds a little bit funny, but what I'm trying to say is there's or operation, and as long as there's 1, no matter what is here on the other side, you always get 1. You see, as long as you have 1 here, no matter what we have on the another side, you always get 1. As long as you have 1 on one side, you don't care about another side, you always get 1. So this is about the or. So two rules. For or, as long as you have 1, don't worry about another one. You always get 1. Otherwise, if there's no ones, if there's at least 1, then you get 1. But if there's no ones, then you get 0. So there's 1, 1, you get 1. 2 ones is fine, but at least there should be a minimum 1 to get 1. Otherwise, always 0. So there's 1, 1, so you get 1. Here's at least 1, 1 here, so you get 1. But other than that, you always get 0. So that means 0 and 0 is 0. And now in case of AND, as long as both are 1s or 2 1s, then you get 1. And in any case besides that one, you always get 0. So if there are no 2 1s, you always get 0. And in the OR, at least 1 1 is present, you always get 1. Now this is about OR in AND bit operation. Now here, this is where we started. So let me join back to our context where we started from. I started off. So here I was asking, what if someone knows the ASCII value and found out the ASCII or the numeral related, the corresponding to that alphabet is 0. They found the 0 position. Now they're wondering how they could change this 0 into 1. Now we can use either, we can use one of these. Now make a guess. How can you make 0? How can you turn 0 into 1? Here. Where is it? You see? Here. As long as there is 1 1 for the OR. Let me state it again. This is very important and we need it. As long as there is 1, you see how many ones there? There is just 1 1. We don't care about another side. As long as there is 1 1, then you always get 1. So here what you want to do, you want to OR 0 with 1 and you will get 1. So if you want to turn this 0 into 1, all you need to do is OR with 1. So when you OR 0 with 1, you will turn this into 1. Very simple, very easy. Now, so I'm gonna move from A, B, C. So I found A minus A 0, and now once I found A, I turned this into 1 by ORing 1. Okay. Now again, I'm moving to B, and what is the value for B? It's 1. Now here, how are you gonna turn this into 1? Again, ORing. How do you OR? So here, let me show you guys here again. Earlier I showed you only ORing just 1 bit or ending just 1 bit, but here, how do you OR either more than 1 bit? I have 1 0 0 1, and I want to OR this with here 1 1 1 0. How do you OR it? As long as there is 1 1, we always get 1. There is 1 1, so we always get 1. That means we are ORing 0 with 1. As long as there's 1, we always get 1. As long as there's 1, we always get 1. And here also, as long as there's 1, yeah, it has 2, but what's the minimum condition? Just 1. As long as we have 1 1, we get 1. So if we OR 1 0 0 1 with 1 1 1 0. The result would be 1 1 1 1. Okay, now here your question might be, we have a, let's say, like this. It's a 0 and it has 32 bits. Now we already put 1 here, so it was like 0 0 0 0 0 0 0, and we ORed with 1 and we got 1 0 0 0 0 0. So this is here. This is how we got here. But now you might be thinking, there might be a question where you would be like, how can I make this one? This is not like, the one at the last on the rightmost side. It's here. It's like this. It's one a bit after the rightmost one. So how can we turn this into 1 without changing this, the rightmost or the least significant bit? So what we can do? OR. But OR what? Should we OR 0? If you OR 0, then you will get the same thing again. Okay, now what you can do here is OR 1 0. 1 0. If you OR 1 0, you'll get what? Look, the rule for the OR is as long, sorry, my pen. As long as 1 1, as long as there is 1 1, you'll always get 1. So we're ORing these two. So here's 1 1, so I get 1. As long as 1 1, I don't care about how many zeros. As long as there's 1 1, I get a 1. Now you see what we're getting. We're getting 0 0 0, and the 0th position is already 1. It was already 1. It's still 1. And now the another position, second position, or the base position also became 1. How did you do that? We ORed 1 0. Now another question arises here. How did we get that 1 0? Because it's easy to OR 0. It's 0, it's just 0. So this 1 0, how do we get 1 0? Now I forgot to mention about another bit operations which is used here. I'm sorry about that. So let me explain here. So let me connect back to the logic. How to make this 1? To make this 1, we have to OR 1 0. But how to get 1 0? Maybe, later we might have to get 1 here and here. And in that case, we need 1 0 0 0. But how do we get that? So how do we get that? Okay, so for that one, let me show you this. For A we got 0. For B we got 1. Likewise for C, we'll get 2. D, 3. You see, here's 0, 1, 2, 3, 4, 5. So it's increasing linearly. So here, when we had 0, we ORed just 1. We ORed just 1 here. So it was 0 in the beginning, and we ORed just 1, and we got this. When it was A means 0. But when we have B, that means 1. So we need to, or what to get 1 0? We need to put 1. We need to add 1 0 after ones. If it is 2, we need to add 2 zeros. If it is 3, we need to add 3 zeros. So on the third position, if you want to make it 1, then I have to OR this whole thing with 1. Then how many zeros? 1, 2, 3. So this 1 would convert this 0 into 1, and these zeros would not change any of these. If they're 1, they will still be 1. If they're zeros, they will still be zeros if we OR. So these numbers would tell us to add how many zeros after 1. So, and how do we add zeros on 1 in here? It's pretty simple. And this is when we will use shift operation. So there are two shift, actually two kinds, and one's signed, one's unsigned, but I'm going to talk about the left and right shift here. So left shift is denoted by this. Sorry, I'm very bad at using this pen. I'm just learning. And right shift, so this pointed, you see the pointed, it's pointed towards left. That means it's left shift. Pointed towards right, that means right shift. Now this is the shifting symbol. Now what are we going to shift? We're going to shift 1. So after this operator, how many times you want to shift? Like how many bits you want to shift over? So if you put 1, it will shift this towards left 1 bit. So we were wondering here, how can we add 3 zeros after 1? By shifting 3 times. If you shift 1 time, it will give you 1 0. If you shift 2 times, it will give 2 zeros. If you shift 3 times, it will give 3 zeros. So this position number, this ASCII number, or the number we derived by using ASCII, is gonna give you the number of positions you wanna shift left. Once you shift that many bits over to left, you get this number. In the 32 bits, or in integer, if you shift towards left, you can shift up to 31 bits, right? After 31, it's gonna start over. So if you shift 32 times, that it's gonna act as shifting 0 times, because that's how they have designed in Java. The same way, if you want to shift right, and if you're shifting, you can shift up to 31 times. And if you reach 32, that's gonna go down to 0 again. So whatever the number you use after this operand, that's gonna be the modulus of 32. So 31 modulus 32 is still 31. So you can shift up to 31, but if that's 32, then it's gonna be 0. If that's 33, then it's gonna be 1. So shifting shifting 1 like 33 times is gonna be like shifting it like 1 time, because that's how they have designed in Java. I don't want to go over this topic, because here only what we need is the left shift, and this number will give us how many zeros we can add uh, after 1, and that's all we need. So in the future videos, if I have to explain about this, I can go over uh, about right and left shift. But now let's connect back the logic again. So when we see A, we change this into 1 by ORing, and how to get this number we already discussed. Now when we get B, we change this into 1. When we get C, we change this into 1. Now what after this? Okay, now we put all these ones, so these are not repeating. Now let's say it repeats. So if it repeats, what are we gonna do? How are we gonna find if it's repeating or not? Again, we will use our shift operation. So after ABC, let me delete this as well. Let me write this one. A, B, C, A, B. Okay. So for me to find out if this is repeating, if any character here is repeating, all I need to find is one character. And as long as I find one character is repeating, that's all. I'll be done. It's done. That means, it has non-unique character. So A, we put its information. B, we put its information here, 1. C, we put here. Now again A. Now this is where we need to be not careful, but this is where I would like to make a decision if it is unique or non-unique. Now when we encounter A again in this sequence of characters, now we'll go to this position, and now we'll see there, what is the value? 1. That means if it was 0, in the beginning it was 0, so it was not repeating. So we continued, but now the 1, the value, the bit 1 in the position of A, that's represented by 0, that's 1. That does mean that this character is being repeated. So that's all we needed to know. As long as we know this one, we will tell our method return false, because we are done at this point. We already know A is repeating because I see 1 here. But now the question arises. Okay, I have this number 0, 0, 1, 1, 1, 1. Now, yes, by just looking at it, you can tell me it's repeating. But in program, in Java, in your code, how are you gonna decide if this, the 0th position, we know how to find out the position. We're just gonna we're just gonna left shift by the number of positions. But even after getting the position, how are you gonna find out if this is 1 or what is there? How are you gonna find out if this is 1? Is there a way to find out is there a way to find out if this is 1? Because in the beginning we had all zeros, then later we made these 1s. Now there should be a way to find out the value of this is 1. So this is where we're gonna use the AND operator. AND operator. So what is the rule in AND operator? As long as there are 2 1s, you always get 1. Right? As long as you have 2 1s, you always get 1. If there are no 2 1s, then forget about 1, you always get 0. So what we do is we will come here and we'll end 1. Now if you end 1, 1 and 1, you get what? 1. Now this will be useful to decide if this is 1 or not. Okay, so in case, let's say there it was not 1, it was 0. So what's the um, rule of end? As long as they're both 1s, then only you get 1. Otherwise you get zeros, so you will get 0 here. So this will determine if the value in the given position is 1 or not. So that's what we're going to do here to find out. Let me erase again. To find out if this position has 1 or not, we're going to use AND operator. And we'll end with the position. And how to find the position? We left shift by number of positions here. And we'll find this number, and we're gonna end. Okay, now still it's not complete. Still not complete. So if we end this one, we get 1. Okay, that's okay. But now, still, how are you gonna tell this is, okay, now we know this is 1, but how are you how are you gonna decide this is repeating? So let me put this way. I have 1 here. I was checking. I just wanted to see if it was 1 or not. Now I found it's 1. Now what? Okay. Now you will compare the whole result with 0. If the whole result after ending with 1, if that's greater than 0, that means it was 1. Okay. Now it might be a little bit confusing. You might be saying, hey man, if it is 1, then yeah, definitely you'll get 1, which would be greater than 0, and you would tell us, A is repeated. But what about these ones? Here is another one here, another one here, another one here. Okay. Now how it works here in 32-bit int is, when you have 1, you won't be just having just 1. Because in int, we have how many bits? 32 bits. So there should be altogether 32 bits. And this is 1. This is 1, and all these are 31 zeros. Okay, so when I'm ending all these, this number, the container with this 1, it's not like I'm just having 1. I have preceding zeros here. Okay, now this will answer your question if you have any questions there. Why it would be greater than 0. And why these ones would not affect the whole value after we end this container with this 1. So now what happens? So the rule of the end is, as long as there are 2 1s, you get 1s. Otherwise, always 0. So here, there are 2 1s. That's why we got 1. But these all will be zeros. And this one would be always greater than 0. So now we found out this is repeating. Now let's say there's another situation. Let's say A is not repeating here. Um, C is C is repeating. Okay. Now this is A's position. This is B's position. This is C's position. Not like this. My bad. 1, 2. Now we put A, B, C. So we put A, B, C. Now C is the one after C. So this is repeating. Now this is the C's position. Now we have to end because we know how to find the position by left shifting. So we know it's the we're shifting how many times? 2 times. So if we shift 1 left 2 times, we'll get 1, 0, 0. So we will be doing this. Okay. Now again here, it will make it clear. These would be zeros. And everything else here would be 0. So if you end, you see, all these values significance would be gone. This 1, because we're ending, since we're ending, there should be 2 ones. So it's just 1, 1. So we'll get 0, 0, only this, and everything would be 0. That's how these ones, any ones after or before this would not, contribute to find out if the given position has 1 or not. Because even if they have 1s or 0s, it will turn them into 0s. So finally, what matters? The value in here, because these zeros would null, cancel their presence. Since I'm going to call this in a main method, which is static method, so I'm going to make it a static method. It's going to be public. You can make it private, doesn't matter. You can leave it default, doesn't matter. But I'm going to make it static, since I'm going to call this from static method. Public static. It has a return type because we're going to find out if it's all unique characters or not. So that's Boolean. So Boolean. Public static Boolean. And now name of the method, I'll say all unique. You can put your own name. It's up to you. And the parameter here is a string, because we will be given a string, str, in the method body here. Okay. Now, I'll try to explain as much as possible while I'm coding here. And don't worry, I'll put this into the code as well, so that you will be able to test. So first of all, I'm gonna be doing for loop, because we need to see what is repeating, what is not repeating. So first we have to put these into the integer position holder, right? Because we're gonna use integer, 32-bit integer. So here, first I'll declare, even before running the loop, I'll declare an int. I'll call it position holder. You can call it anything you want. Position holder equals 0. Now this method is giving me this space, this container, where I'm gonna put the information about my characters. And these are all bunch of zeros, and there are 32 zeros right now because we just declared. Okay, now after this I'm gonna run a for loop, because I need to access all these one after another. So for I'm gonna use int I equals 0. I is less than. So less than what? The length of the string. Length. You might be saying, why less? Why not equals? Because length of a string is, if it is 5, it's the string is 0 indexed. So it starts from 0, 1, 2, 3, 4. So that's why 4 is less than 5. So we're going to go until 4. And 4 is less than 5. And less than 5 means less than string dot length. And what's the increment? Since we're going to access, or the, sorry, I'm just learning to use um, this thing. So we are accessing, oh no, D, E, A, B, one after another. So increment would be just one. And folks, if I'm explaining too much or like too tiny things, excuse me, because I would like to make it as simple as possible. So even though it's time consuming, people might have doubts. So that I'm just trying to be so basic. If you, I know you already know. If you know, then just skip it or fast forward this portion. And now for loop, opening and closing for this for loop. Now it's time to find out the position with respect to ASCII value. Now how do we get the ASCII value? So it's very simple. What we'll do is, let me find the position first. I'm gonna make it int position equals. Now there is a method called string dot character at, and you give the index here. So what does it give you? A string dot character at. So if this is the string, and if you give the character at, and if this is 0, 1, so this will give a. But since this is int, that its ASCII value would be put into the position, right? So the string dot char at is gonna give us 97, but we don't want 97. What do we want? We want 0. So we know, I already I already showed you guys how to make it 0. Minus, you could do 97. And how do we do 97? By subtracting a. So it will get its ASCII value, which is 97, and it will get its ASCII value a, that's 97 and 0. Now the position is 0. Now we know what's the position. It's 0 for a. Now we are here. Sorry, let me read. That's 32-bit long, okay? Okay. This is the 0 position. This is for a. And these are all zeros. All zeros. Okay, now we found the position. After finding the position, now what are we gonna do? This is what is this? This is the position holder. This is this. Now we have to OR this position holder with 1, right? But how are we gonna do get 1? Simple. We just put 1. But just to make it useful for all characters, what we will do, we will shift 1 this position. So we'll shift 1 by this position. So this is what we'll do. Let's see. I can make it a mask, I guess. I can write it as mask equals 1, and you're gonna left shift by this position. So I'm writing these here. These you might be like, why do you need all these? You don't have to write position, have position and mask. You can put all these together, but just for the sake of understanding, I'm having different variables like position and mask. Now once we have mask, this is the one we're gonna end with position holder so that we can add one. So what we'll do here, we will end. I'm sorry, I will OR, because we're going to add one there. So how to OR? Simple. Position holder equals, we're going to OR and we're going to assign to itself. So position holder, and this is the OR symbol, the straight vertical bar, with this mask. Okay. Now there is a shortcut for this one. Instead of writing this, you can also write like this, and you don't have to write this position holder. You don't have to write this position holder and OR. So it's gonna be mask only. Okay, now this is the loop to put all these. Now when we get A, we're gonna make it 1. When we get B, we're gonna make it 1. So it's the same same position holder. We're not using extra space, extra int. It's the same int. Once we have, let's see, we reached B, we reached D, E, C, D, E, and again A. Now let me change this. Okay. Series A, B, C, D, E, and these are unused ones. These are unused zeros. Now once we reach E, now we are getting A, because while we're doing loop, we're getting A. Now when we come to the position of A already has 1. So how to find out this 1 there? So by using if. So if what? We use position holder and we already discussed, we're gonna end this whole thing with this mask and mask. When we do this, I don't know if I can get here, and position holder or equals mask. This is when there's all zeros. But what if it is already 1 there? So in that case, we'll check. First we'll check. So that's the reason I put this position holder and mask. I'm just checking if this position has already 1 or not. So once we check if it's not there, then we're going to put this. Otherwise, we'll return false. So if position holder and mask, if we end this, and if that value is, okay, so let's add that one. If this value is greater than 0, in that case, what you want to do is just return false. Return false. Because when you're seeing here, it's 1, so that means it's repeating. So how did we find, how can we find if it's 1 or not? By, finding, by ending this whole thing with the mask, and mask contains 1 and bunch of zeros, and those zeros are added according to the position of that letter. So if that's 0, then we're going to return false. If that's not 0, then we keep adding. So this is the whole. And now, so when we do the for loop, first we go and get the position of that character, and we create a mask, and then we'll check if it's 1 or 0. If it is 1, we return. If it's not 1, then it continues, and what happens? We add 1. Now this whole thing goes on, keeps going on, and there's no 1. Okay, there is it doesn't find any 1s. It has only zeros. Then this for loop will end, and after that here we will return true, because there's no repetition. Let me open my Eclipse. Where's my Eclipse? Okay, and I'll copy exactly same thing. There won't be any change. Okay, so I told you, like, I'm gonna use static because I'm calling this from this main, and this is static method, and static method can only call static methods. That's why I'm making it public static. You can leave it private, or you can make it default, doesn't matter, but I just wrote public static boolean all unique, and the parameter is string str. Now I'm declaring the position holder. I'm calling it position holder. If it sounds weird, you can name it it's for your desire. So it's position holder. I'm putting position holder because it holds the positions for the characters. And now I'm using for loop for int I equals 0, I is less than the length I plus plus, and then int position equals char at I and minus a. That's the position, and int mask equals 1 left shifted by position bits, position, and then now we're checking if it is 1 or not. If it is 0, this code would not execute. So we're just checking if it is 1. In that case, it's repeating. So if position holder end, this is the end, holder and mask. Okay, so let's put this into parenthesis. Is greater than 0. In that case, we will return false because we found it's repeating. This is the one that tells us if it's repeating or not. If not, you can also use else here, not a big deal. Since there's return, if it hits this, it won't be executing after return. That's why I didn't use else, but you could use else there. Position holder equals mask. So you're ORing with mask. Now, after how many? So here at the last, in case nothing happened here, so that means it didn't find any repetition. That's why it did not return false. So it kept adding ones. It didn't find any repetition. So that means it was all unique. So we're gonna return true. Oop. This is our method. Now let's test it. A string str equals a b c d e f g. Okay, so this should be unique. So let me print out all unique, all unique str. Nothing's repeating, so it should give us true. If not, oh no, it gave us true. Now let's repeat a. I want to put a here. It should give us false. Let's do this a b b c c. False. False. True. Okay, now earlier I said we can use long. Long could hold up to 64 bits, so it can hold more than int could hold because int could hold only 32 bits. So what if you want to use long? Yeah, you can do that. Just make it long and oh my bad, long, and here where is it? Okay, and in the position also L. No, here's long, and you can do here L. Okay, let's run this. There we go. AB. AB. B. Okay. Now you might be asking, hey dude, it doesn't work for these weird characters or space. So let's see. False, but how about this one? Is just one space? True. Two spaces. True. Okay, so two spaces should not have been true. It should have been false. Okay, so the constraint for this approach is, since a long or an int, and an int could hold only 32 bits. So that means we can have only from 0 to 32 values. So the A, so for the characters letters from A to Z, it's 97 times plus 26. So we just made it pull those back to 0, and we made them 0 based. So A became 0, B became 1 that way. So it became up to 26. And the int could hold only 32. And long could hold only 64. So that's the constraint. If you want to add a space, then first you need to find out what is the ASCII value of space. So there are like 258 ASCIIs. So we cannot hold all of them here in this approach. So for that one, we do need to use an extra space or data structure. We can't solve without using the data structure or the brute force. So thank you very much.